Let's think back to Le Chatelier's principle. What happens if we add one of the products into the reaction? Well, Le Chatelier said that if we add a product into the reaction, it's going to shift the equilibrium towards the reactants. That's the same idea that happens if we have a common ion in a solubility situation. So if we have the same ion that is in the product, it is going to shift the equilibrium towards the reactants, making our solubility even less for our insoluble salts. So remember, solubility is a continuum. Even though it's insoluble, a very tiny amount will dissolve. So our example here, we have sodium fluoride. If we add sodium fluoride into a solution that contains calcium fluoride, it's going to shift the equilibrium towards the reactants, which is the solid. And so this can help us in chemical reactions if we want to crystallize a product out. If we want to form crystals, we can take advantage of this situation. We can also use pH to help us shift our solubility. So if we have an hydrate or a hydroxide, if we increase the pH, because of our hydroxide being on the product side, it's going to shift the equilibrium towards the solid or towards the reactants. And so if we decrease the pH, if we remove hydroxide ions, it's going to shift it towards the product side. And so we can use pH to help us modify how much of our salt dissolves into the solution. And so this is also the case when we have anions of weak acids. That can also adjust the solubility to make things more soluble in solution by shifting our equilibrium. Let's say that we want to know about if a precipitate forms or a precipitate won't form. This depends on the solubility of the ionic compound, and it will happen if the concentrations of the ions exceed the solubility. So we can compare our reaction quotient Q, which happens at any point, to the KSP. And by doing this, we can see if a precipitate forms or not. If Q is equal to KSP, it's a saturated solution, so we're just on the borderline of a precipitate forming. If the KSP is bigger, that means that we have to have more ions before a precipitate forms, so we won't get a precipitate. If Q is larger, it means it's above the saturation point, and we are going to get a precipitate. So there are some instances, and we've already looked at these a little bit, is supersaturated solutions. That's where we very carefully make the solution so that the Q is larger, but they're very unstable. If you disturb them in any way or add a crystal, they will precipitate very quickly. So if our Q is larger than KSP, we get the solid to form in the solution. Here we have an example of silver chromate forming. If we have a supersaturated solution, we add just a tiny disturbance like a seed crystal, a place for the crystallization to start. All of that will crystallize very quickly. So the sodium acetate is a good example that is relatively easy to form supersaturated solutions. We want to determine if a precipitate will form when we mix lead nitrate, lead 2 nitrate, with sodium bromide. We have the concentration of the lead 2 nitrate, we have the concentration of the sodium bromide, and we need to think about what is going to react in order to form our precipitate. So the lead is going to react with the bromine in order to form lead bromide, which is insoluble, and then we also have sodium nitrate, which is soluble. The KSP of lead bromide is 4.67 times 10 to the negative 6. And so in order to calculate this, we want to compare Q to that KSP. So the Q that we want to calculate is going to be for the lead bromide. So we know that there is 1 lead and there are 2 bromides. And so because there's 2 of them, we have to square the bromide. So now we can plug in our concentrations. Because there's only 1 lead, the concentration of lead nitrate is going to be equal to the concentration of lead. Because there's only 1 bromide in our aqueous solution, the bromide is going to be equal to the concentration of the sodium bromide. But we have to square that whole concentration. And so we end up with a Q that equals 1.84 times 10 to the negative 5th. Now we want to compare this to the KSP. So our Q value is larger than the KSP. And so that means that we will get a precipitate. The precipitate will form of lead bromide. All right, try the practice problem to see if a precipitate forms when we mix calcium nitrate and sodium hydroxide. So our equation is going to be calcium nitrate plus sodium hydroxide and we're going to form calcium hydroxide and sodium nitrate. And this is going to be aqueous because anything containing sodium or nitrate is always soluble. Our calcium hydroxide will form a solid. Now we need to balance this reaction. And so we have 2 hydroxides, so we're going to need a 2 in front of our sodium hydroxide. That's going to change the amount of sodium, so we need a 2 here, and then our equation should be balanced. So for our KSP, we're looking at calcium hydroxide dissociating to give us calcium 2+ and 2 hydroxides. So our Q is going to be the calcium concentration times the hydroxide concentration squared. Now because there's only 1 calcium in our calcium nitrate, that's going to be equal to the concentration of calcium nitrate. Sodium hydroxide, again, there's only 1 sodium hydroxide, so that will be equal to the concentration. Sodium hydroxide, we have to square it. We end up with 5.36 times 10 to the negative 6th power. We want to compare that to our KSP. And so our Q is larger than our KSP, just a little bit. And we do get a precipitate of calcium hydroxide that forms. What if we want to figure out when a precipitate is going to form? So say we have magnesium and seawater and we want to figure out how much hydroxide we need to use. Well, we are going to look at our precipitation reaction. And we are going to look at when Q is equal to KSP, because any point above that is going to be where our precipitate forms. So we are going to look at our Q value. We know the magnesium concentration. We are trying to figure out the hydroxide concentration. And so what we're going to do is set it equal to the KSP to see just when that would happen. So we know we're going to solve this for OH minus. And so we're going to get the KSP divided by the magnesium concentration. And that's going to be the square root so that we can get the hydroxide concentration. So now we can plug some numbers into this. We know that our KSP is 2.06 times 10 to the negative 13. Our magnesium concentration is 0.059 molar. I'll take the square root of that. And so our hydroxide concentration, anything over 1.9 times 10 to the negative 6 will form a precipitate. Now you try the practice. So we're going to look at the minimum concentration of calcium nitrate that will precipitate calcium hydroxide. We're given the hydroxide concentration. So calcium hydroxide is what we're interested in. That's our solid. We know our KSP, and so we are going to figure out when Q is equal to KSP, our calcium concentration, hydroxide concentration. So in this case, we know the hydroxide concentration. We're trying to figure out calcium. So we can plug in our values here. Our calcium concentration, we would divide by our hydroxide squared to the other side. Our calcium would be 1.53 times 10 to the minus 2. So this would have to be the amount that's also going to be equal to the calcium nitrate concentration that we would have to add to form this precipitate.